Good morning, everyone. The goal for this week is to finish with Lisp. Today or the next lecture, we complete what we need to review regarding Lisp. Therefore, the goal is next week, start with Prolog, just to let you know about the schedule. Now, because this week we finish with Lisp, you can expect that by the end of the week, you're going to have open the next assignment and a new quiz. So review everything that we have done with Lisp. We should finish this week, and then you're going to have a week to work in a new assignment and a new quiz. As usual, the quiz, a couple of questions to answer in less than an hour, multiple choice, and the programming assignment. The programming assignment, this time, you're going to notice is going to be a little bit easier. I mean, compared with Java, C, and C++, and all these questions about multidimensional arrays, dynamic memory, and so on, you're going to notice moving to Lisp is going to be probably the easiest assignment that you have done, at least in the class. Anyway, please, it's going to open this week, probably after our next lecture, and you're going to have 1 week to work. Do not procrastinate, start working as soon as possible, and be sure to submit. Again, it's probably the simple, easiest assignment, so it could be a good option to improve your final grade. It's an assignment in which hopefully you can easily get full points. Good. So for the assignment, moving forward, next topic with Lisp, we know how to use functions. We know what is a function. We know that the first word inside of the parentheses represents the name of the function. Next step, finally, we need to learn how to create our own functions with Lisp. That is something that we need to do today. So functions with Lisp, easy. If I want to do something in Lisp, I need a function for doing that. And even if I want to create a new function, well, we have a function to create functions. And the name for that function, the fun, a definition of a function. So you want to create a new function, what we call methods in Java and C++. The first thing that you need, open parentheses, and the fun. Next, the second element. The second element, the name of the function. Whatever name you want to put to the function, 1 word or more, and use a reminder. Here, if you want to put 2 words together, we do not use this idea of uppercase, lowercase. We do not use the underscore. Here is more common to have what used to be the minus to connect words. So the fun and the name. To be clear, you can make this in 1 line, a big line. That could work. I am going to use enters, and I am going to have several different lines just to make this easy to read. And usually you are going to do the same in your programs. Several lines, split things to facilitate the reading. But for your interpreter, you can put everything in 1 line. There is no rule. There is no mandatory to create these enters or tabs. So the func, name of the function, and then the parameters. The parameters, a list with the parameters. Open parentheses, closing parentheses, inside the name of the parameters. Obviously, the only reason because you put the names of the parameters is because the number of words that you put there is the number of parameters that you are going to receive. Moreover, those names are the local variables that you can use inside of the function to use whatever you receive when your function is called. So the func, the name, inside of parentheses, the parameters, only the name. Remember, there is no data types. And after that, whatever you want to put here are the instructions inside of your function. That's it. Open parentheses, closing parentheses, the name of the function, inside of parentheses, the name of the parameters, and all the instructions. And as you remember, each instruction is going to be something inside of parentheses. So a function in Lisp, the definition of the function is going to look like my following examples. The easy one. Parentheses, definition of a function. It's very small, so I am using only one line. No need for the enters. It's easy to read. Definition of a function. Name of the function. Can we agree that the name of the function is do hello world? It is not mandatory to use those big names. It is not mandatory to use the minus in the name. I am going to give you an example here with only one word. I am going to give you an example here with 2 words and the minus. You have this example with a very long name. The name is whatever you want. The only thing here in the examples is I want to be sure that you remember that the minus is not minus. We're not doing an operation. It's part of the name. Do hello world. This function do not have parameters. It's the easy function ever. No parameters. You need the parentheses. You need the parentheses because this is the place for the parameters. You should put the parentheses. And even though they are empty, that is telling the interpreter that you are creating, defining a new function, do hello world, and that function is not going to have any parameter. So after that, the instructions inside of parentheses help me to remember what happened when you put something and that something do not have parentheses. There are 2 cases. You can put values like this, is a string, or you can put variables without the parentheses. Do you remember the meaning? No. When you put something without parentheses, like a variable, you are asking the virtual machine to give you the value of that. You can put the name of a variable without parentheses, without any instruction, and the virtual machine understands that you want to know the value for that variable. You can put a value without parentheses, and the virtual machine understands that that is a value. This is a value. Is the last instruction inside of the function. What is going to happen is that one is going to be the value that the function returns. Just as we reviewed before, every single function returns something. The return for our function is going to be the result of the last instruction inside of the function. In the declaration of your function, whatever is the result of this function, the last one, that is going to be the full return for the new function that you are creating. What happens if I put at the end, not an instruction, but use a variable or use a string? If you put a function, whatever that function returns, it's going to be returned. If you put a variable, the value of the variable is going to be returned. If you put a value, a number, or a string, that is what is going to be returned because it's the last thing inside of the function. In this example, what I have is a function that returns hello world. If I ask you to translate this to Java, what you have here is a function with the name. Notice that I am changing the notation to Java without parameters. And inside, I only have this. And because it's the last line, that is going to be returned. Now, something is missing here, the data type for the function. There is nothing here that establishes the data type. The interpreter is the one that is going to think about it and is going to decide that because I am returning hello world, if this is Java, that is the equivalent to the function that I showed you. A function that returns a string. In real time, I'm going to note that this is string because I am returning hello world. No parameters, only one instruction. That instruction, the last line, is what I want to return. Well, because we do not have a class here, I mean, this is more like C, is a function outside everything. There is no need for an access modifier. If we think about this being a class, probably just following the standard, this could be public. But again, in this particular case, it's more like a function in a structural paradigm. Make sense? Excuse me. So, one function that returns something. There is no return instruction and there is no data types. Now, what happens when you do this? When you define a new function, enter, the interpreter is going to tell you, I understand now your function by returning the name of the function in uppercase. When you create a new function and you press enter, remember, one thing is the definition of the function, creating the method, and a different thing is to call the method. When you define the function, you are using the instruction defun. It's an instruction. It's going to return something. It's going to return the name of the function in uppercase. Then, in a second step, you call your function. Calling your function is like this line is different than this one, right? Definition of the function, calling the function. In Lisp, you can call the function without creating another method, without creating another function. So far, everything that we have done have been instructions that are not inside of anything. You call your function, parentheses. The first element is the name of the function. After that, the parameters. This function do not have parameters. Therefore, open parentheses, name of the function, closing parentheses. Only one word inside of the parentheses. I am calling my function, and what I'm going to get as a result is hello world. I do not have a print, but I call the function returns the string, and as usual, the interpreter is going to print whatever received as a return value. If you are using the interpreter online, probably what you want to do is parentheses, print, parentheses, do hello world. Because remember, the online interpreter is not going to print by default. You need to ask for the printing. So print, the parameter for print, calling your new function, do hello world, closing the parentheses for the print, done. It's going to print what do hello world return, do hello world return, hello world, a string. Good. That is the easy one. Now, second example. Second example, what happens if I want a function, another name, whatever name you want to use. But now I want parameters. The easy one, a function with one parameter. Notice, parentheses, one parameter, only the name of the parameter, X, Y, C, W, a big word. It doesn't matter. The name that you want to use, you do not need data types. No data types. this function add 4 receive one parameter, and the parameter is x. One instruction inside. The instruction inside, an addition. What I am going to do, add 4. Notice that the x, the parameter, is a local variable. I can use that local variable for whatever I am going to do inside of the function. Local variables, just like let, but these are the parameters of the function. X with an addition, adding something. Moreover, this one is the only instruction inside of the function. If the last one, add 4, is going to return the result of that thing. Thinking about moving this function to Java. This function is something like add 4. I am changing the name to follow the standard. One parameter, x. The interpreter is going to figure out, because I am going to use that parameter in an addition, that this one is a number. And probably by default, it's going to use the type integer. Then I want to do x plus 4. That is the operation. But because it's the last line also, that one is what you return. This function in Lisp is something like this: add 4, one parameter, integer, return the addition of that integer with the number 4. And the interpreter is going to infer that because I am returning the result of adding an integer plus the number 4, that is another integer, well, that is the equivalent in Java for this function definition. It's a function with the name add 4, with one parameter that later we discover is an integer, and it's going to have only one instruction. That one is going to be also the return value, x plus 4. This, the definition. Later, in some point in my program, I can call my function. In Java, C, C++, add 4, the name, parentheses, and I could send a parameter. This is the calling for the function. In Lisp, parentheses, the name of my new function, add 4, space, the parameter, the number 7. This is calling a function in Lisp. This is the equivalent in Java, for instance. Obviously, if we're talking about Java or C, this guy should be inside of another method. This guy should be inside of another function. Calling a function should happen inside of another one, at least inside of main. That is not the case with Lisp. You can just call your function in the console, and you are not creating any main or anything similar. It works. When you call this one return an integer, 7 plus 4, 11. Automatically, you're going to get the result printed on the screen if you are using the interpreter in your computer. If you are using the interpreter online, again, open parentheses, print, open parentheses again, and here you can call the other one. And with this one, you are asking for printing the result. That one is going to work in the online. If you use that one in your local interpreter, it's going to print twice 11, one because the return and one because the print, as we reviewed before. So a new function, one parameter, return an integer, return a string. Can you notice? It's just, I want to return this. I want to return this. And I am not worried about, it's going to be an integer, it's going to be a long, it's going to be double float, it's going to be small or short, bigger, I don't care. It's going to be a string, how many characters? It's going to be a pointer, a reference, an object string. We don't care. I want to return that group of characters, period. One more. Another example. Here, I have another function. That function, hypotenuse, and that one is going to receive two parameters. How do you know that there are two parameters? There are two words inside of the parentheses. Each word is one parameter. Remember, do not expect to read a comma here. No commas. Two parameters, length and height, and then the instruction. How many instructions do I have inside? Again, one, but a big one. Now, just because it's one, again, that is going to be the return value for the function. This function is going to return whatever is the result of the square root of the addition of something, multiplication of two things. Hopefully, you agree with me that here, what is going to happen first is the multiplication of something, and then that one is going to be added with the multiplication of something. Multiplication, multiplication, addition. And then you're going to do the square root of whatever you multiply here and here, add it. Yeah, the hypotenuse for a triangle. This is one instruction, and basically you're going to return whatever is the result of that. If we think about Java, this instruction is something like, well, name of the function, two parameters. They are going to be involved in multiplications and additions, so probably they are going to be numeric. And inside is only one instruction, so that one is the one that is going to have the return. I want to use a square root. Because I want to use a square root, I'm going to be calling math_sqrt. And if I am calling math_sqrt, then probably I just figure out the return type for the function. This is a function double. The name is hypotenuse and receive two parameters. They are integers in Java. And inside, the instruction that is happening is one, return math_sqrt, and the math_sqrt is something like plus you can complete the words. Public. Just answering the question there. If you are asked to convert this one to Java, you can put public, like any method is public, it's fine. So this could be kind of the equivalent. No parameters, one parameter, two parameters. Always the last instruction is the one that is going to provide the return value. Here, when you call, you do something like this. In Java, it will be 7,9. Here, 7,9 without the comma, the parentheses enclosing everything, and the return values. So far, easy, right? Hopefully. Now, something more complex is like, okay, those three examples, different parameters, but the body is only one line. Too simple. Something more complex. Something more complex, well, what if what I want is a function, and inside of that function, I want conditions or loops or multiple things happening? Similar idea. The syntaxis, you already know it, is very simple. Use parentheses. Definition of a function. Name of the function. All the things in red. That is the name for the function. First n characters. Help me, how many parameters do we have in this function? Everyone agreed, 3, right? Very, very important, guys. I can use a string here. Even I can use int, float, double. I can use those words. They were data types in Java, in C, in other languages. Here, they do not mean anything. They are just words, and I can use them as names for my parameters. Here, very common mistake, thinking like, oh, this is the data type for the parameter. So the parameter is n, and it's going to be a string. There is no data types here. So string is the name for the variable. Parameter number 1. Parameter number 2, n. One is a word, and the other is just one character. It is fine. String, n, and the other have uppercases. Moreover, have a minus symbol. It's just one word. The line is not the minus. The line is just part of the words. Here, it's like your underscore. Reverse it. Moreover, the uppercase, remember, this is not case sensitive. You can use uppercase, lower cases with the variables, also with the functions. We're going to talk about it. So 3 parameters, good. Inside, 1 instruction, again, now it's an if. Open parentheses for the instruction, the if, and that one is going to close there. The if, we need to remember which are the elements for the if. Element number 1, the first parameter for the if, the condition, a Boolean value. A Boolean value, and the only thing that I am putting here is one of the parameters. Can you imagine that what is going to happen here is that the interpreter is going to understand that the data type for this parameter should be Boolean. I am using that parameter as a variable for a condition. The value for that parameter should be a Boolean value. Is true, is false, T or nil. In fact, if you notice the calls for the function, I am going to test the function using as a third parameter nil, the equivalent to false, the representation of false, and T, the representation of true. Also, in the last one, I am going to use a number. And as you can imagine, this number is going to be the value for this parameter. No problem, there is no data types. That variable can receive nil and can receive true and can receive the integer number 2013. It can work. What is going to happen with the if? Because in some point, I am going to be doing if 21.3. If 21.3 is going to be true or false, what is going to be the rule here? Or is it going to be an error? Well, according with the results that I am showing you, it's not an error, and as you mentioned, it's true. What is the rule for Lisp? The same rule, similar rule that we have before. If you tell me nil, nil is false. If you tell me any other thing, true. T, true. A number, a string, any value different from nil, true. Same result with the number than with the T. Default things. Anyway, so the if, the condition, then 2 instructions. One instruction that is the if part, another instruction that is the else part. Okay. Instruction number 1, subseq Instruction number 2, the same, subseq. Subseq, we reviewed this before, is a substring, basically. A substring, I want a substring, and that substring is going to go from the element 0 to the element n. By the way, the element n is a parameter. I am receiving as a parameter in which character I want to stop. Moreover, I am also receiving as a parameter the string. If the condition is true, I return a substring. I return a substring from the character 0 always to the character n. The character n is my second parameter. I am using 5 in all the cases. And I am using the same string. If the condition is false, like here, this instruction is executed. And because this instruction is executed, the result of this instruction is returned to if. But if is the only instruction inside of the definition of the function, that is going to be the return for the full function. When I call my function with this string, with this 5, and for the condition false, I am running this subseq, and I am getting the characters from the 0 to the 5 in the string. My result is the first 6 characters in the string, so my first characters. Okay, it's going to be something like this. What happens when the condition is false? Well, when the condition is false, it's the same instruction, but I am adding, instead of use the string, I am using the string as a parameter to call another function, reverse. And if you remember reverse, put the character in inverse order. In these 2 examples, because the condition is true, the first thing that I do is the reverse, and after the reverse, the subseq. So instead of the first characters, I get those, but in inverse order. One function with a return, with an if condition, 3 parameters. One parameter is Boolean, the other parameter is a string, and another one is a number. If I ask you in the exam, can you translate this to Java? Can you do that? Let's see. Open question, you will have a text box, and the answer could be something like first and chars, the name for the function. What is going to return? In real time, the interpreter is going to figure out that this one is going to return a string. It has parameters. The first parameter is a string. The second parameter is an integer. And the last one, a Boolean. Your body. Well, for sure you're going to have an if. The if is going to use as a condition this variable. I am using R just to make this short. You have an else. And something important here is for Lisp, the return is here. For Lisp, the return is, we're going to return the if, whatever is the result of the if. When you translate to Java, you need 2 return instructions, not only one. You do not return the if. You cannot return the if. The if do not provide a value. unless you use the question mark operator. You need to play with the fact that you have a return something when the condition is true, and another return, a different one, for what could be the else, or in this case, use the return of the function when the first one didn't happen. And well, here, those returns, you can assume that you have a subseq function in some library and a reverse function in some library, so you can return the call of those functions directly. But the important thing is the type for the values, the type for the function, moreover, the returns. For an if, more than one. That is the translation process. Good. So a function with an if, 3 parameters. Looks good. Exercises. The opposite. It was very easy. I showed you 4 examples in which we have the function in Lisp, and I asked you for the source code in Java. What happened with the opposite? The opposite. What happened if I give you some source code in Java, and now I ask you to create the source code in Lisp? For instance, I am sure that you remember this. One of the examples that you review in CSE240, the factorial in something like, looks like Java. The factorial function. In fact, I have the factorial function. I am using these statics, right? So I do not need to create objects. I can directly call the function from main, and I am printing whatever is the result of calling the factorial from a particular number, and I am transforming the number to a string so I can print whatever is the result. When I call the method, one parameter, one local variable, a loop, something is happening inside of the loop, and at some point, I am going to return something. Can we translate this to Lisp? Do we have the knowledge, the elements to create something like this, but using the instructions in the Lisp language? A question for 5 points in your exam could be something like this. And it's just the first version of the factorial. It's a factorial with a loop. We need to talk about the factorial recursive. One question first, because moving forward with the source code, it's going to work. If you create this program in Java, if you copy paste this to your Java compiler, do you think that having this parameter double and having this function returning a double, I am going to be able to ask for the factorial of 1000 and get a result? We can try. Anyway, factorial of 1000, that one times 1999 times 1998 times 1997. Depending on what you do, but in some point, yeah, that is going to happen. You are going to have an overflow problem. I am sure that you work with the factorial. My question for you, which is the highest number that you can use as an input for calculating a factorial in Java? Believe me, you have a limit. You cannot calculate the factorial of everything because the overflow. You can try your homework, but this one, maybe. That one. That one. I am using the comma just to show you the number, but you do not use the comma in the parameter. I am sure that you're going to find that you have a limit for the factorial in Java. You know what? It doesn't matter which is the limit in Java. Always, 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 the program in Lisp is going to be able to solve more biggest numbers. Java versus Lisp. Lisp. It doesn't matter if the number is this one, this one, this one, this one, or biggest. Lisp is going to continue working after Java give you an overflow. And you can try. Kind of is around those numbers. Is 2 digits, no more. Yeah, in Java. With Lisp, 3, 4, 5 digits is just work. Okay, so you are telling me that one of the advantages is the factorial could still work in Lisp when in Java already crash. Already crash with the integers variables, right? With the primitive data values. You can implement a factorial in Java using a class for bigger integers, and you can get the same result as in Lisp, factorial for biggest numbers. But with the primitive data, like this, it's going to crash with numbers that are 2 digits in the lower scope, like 20 something, less than 50. This code in Lisp, so you can do the testing. This is the source code. I am going to keep the code in the second column, so you can use that as a reference. Let's see. Number one, I am asking you for a function. I am asking you for a function, and the function, the name is factorial. You are going to define a new function, and the function is going to be factorial. I am asking you for one parameter. The parameter is double. I don't care about the data type. One parameter, the parameter name is n. We need local variables, not the parameters. We need local variables. Local variables. Do you remember the instruction to have local variables? Let. This parenthesis is closing the definition of the function. We want to use local variables. The curly brackets of the function, when we want to put local variables inside, those curly brackets become let. Open let, closing let. Everything is my instruction let. If you remember let, two things. Number one, after the instruction, parentheses for all the variables that I need and the values for those variables. Remember, parentheses, and inside I am going to have more parentheses, and inside of those parentheses I have two elements: the name of the value, the name of the variable, and the value for the variable. In this case, I only need one local variable, sum with the value 1. Local variable, sum with the value 1. Local variable, because I am using the instruction let. Inside of let, whatever instructions you want that use that local variable. Okay, that let is basically those curly brackets. I have the variable. Next, I need a loop. Loops in Lisp, we review do times. Parentheses, do times. Do times, do you remember what is the first parameter for the do times? It's a list. It's a list with 2 or 3 elements. 2 elements. The first one, for the first time, is not an instruction. It's the name for a variable. The variable that is going to control the loop. Use like that one. The second one, the stop value. The value that is going to stop the loop. And I want to run this n times. Lisp, Java. I can add a third parameter. The third parameter could be the return thing. I do not want to return anything. Why? This one is not going to be the last line in the let. So the return is going to be the last line in the let. It's not going to be this one. I am fine with this one being nil. Only 2 elements. Next, Next, instructions, both let and do times after the mandatory parameters, after the first thing inside of parentheses. What you can put inside is whatever you want. Inside of the for, the only thing that I have is one instruction. One instruction. We need to remember the presence of the operators. If I review this, what is the operator that is going to happen at the end, the last one to be executed? We can agree the equal. The assignment is going to be the last thing to happen. It's the first thing that I put in Lisp. The equivalent to the equal is the set f, remember? Set f, if this variable do not exist, it's going to create the variable as global. But if the variable exists, as is the case here, the variable already exists and was created as a local, set f is going to be used the equal. It's going to use the assignation. It's not going to create a global variable. The global variable is created only if this name do not exist before. In this case, already exists. In this case, it's going to be an equal. This set f is this first part. What is going to be the value for sum? All of this. And hopefully you can agree that what I have there is sum multiplication for 1 plus I. 1 plus I literally is I plus plus or I plus 1, and it's the same 1 plus I. All of this, the only thing is, remember, this is the name for the function, 1 plus. Here, parentheses, 1 plus the name for the function, number of parameters, only one parameter. Here, in Java, parentheses, mathematical expression, the number 1 plus the variable I. This is not the same than this, different things. I am calling a function here. Here I am using operators. Anyway, what I have is the do times, the instruction, the for, the instruction. And the last thing that I want to do in Java is to return this, return the value of sum. In Lisp, the only thing that I need to do is to write the name of the variable just before closing the parentheses. Why? Whatever you have at the last line for the let is what the let is going to return. You want to return sum? You just put sum. No parentheses needed. You do not need another function. You're not going to do anything else. You just want to return the value of that variable. Just like in the example that I showed 2 slides ago, if you put a value, 5, hello, or a name of a variable like sum, the value inside of that variable is what is going to be returned. This sum alone is the equivalent to this return sum. Common error, guys. There is no never, 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 never parentheses return sum. Do not do that in your exam. There is no return instruction in Lisp. That do not exist. Moreover, you do not need it. This is the correct answer. This is a mistake. You are going to have this in a multiple choice question. Be sure to select this one. These do not exist. Anyway, this is the function in Java. Your function in Lisp. Equivalent. Calling the function. In my previous example, in order to call this one, I need a main, and inside of the main, I need to put all that. Calling the function, printing the things with system out println. Lisp. Factorial. You want the print. print parentheses, and the calling to the function is the parameter for the print. Good. This is the sum one. Remember, double parentheses because it's let and then parentheses. And here I can have x1 and y2 and more. So we need the parentheses for each pair name and value, and a parenthesis that encloses all of them. In this scenario with only one variable, it looks like I need this, I have this, but also I need this. So it looks like parentheses, parentheses, and something alone. But the format for the let. Yep. Good. Okay, this was easy. Like, okay, I have the source code in Java. You can ask me for the Lisp, and I need to remember some things like the loops, the conditions. This one in particular for the local variables. Every time that you have local variables, I am talking about the let, the tricky part of the return, and well, the operations. Moving forward, I am sure that you remember that the factorial have a second version, the recursive version. And with the recursive version, the overflow is still a biggest problem because it's not only about the size of the number, but it's also about the number of copies that you're creating for the function. And I am sure that you have done this in which you call recursively a function. And if you do not stop the calls, or moreover, even if you have a condition for stop the calls, but this is one of the main reasons because you have a stack overflow. Every single time that you call a function, you are creating a new space in the stack. Remember what we reviewed at the beginning of the semester? You call a function and you block in the stack. Even though the call is recursive, one copy, another copy, another copy, another copy. Put a recursive function to work forever and you crash the stack. Your stack is going to be full of copies of the same function, spaces for the same function to work in different versions. Try the recursive version with that number. For sure it's going to crash. Anyway, this is not Java, this is about Lisp. That is the recursive version. Can we translate the recursive version of the factorial to Lisp? Another question in your exam. And again, for your reference, this is the function. This is the Java version. What I want to do is the Lisp version, following the same idea. You want a function, and the name of the function is factorial. Definition of a function, the name is factorial. It's going to have one parameter. The parameter is n. One parameter. Now, here, I do not have local variables. There is no local variables there. Sum is not there. I do not have local variables. I do not need the let. Let, because the local variable. No local variables. No let. What I have there, an if condition. What I need is an if condition. An if condition, good. Now, open parenthesis, if. Then the condition, n lower or equal than 1. The operator, the function ID first, and then the elements type. Lower or equal, n, a number, n, a number. Good. Now, return something in the if, return something in the else. I do not need an else here. I do not have an else. The only thing that I have is after the condition, one instruction, another instruction. Did you notice? You want to return 1. I do not need parentheses. I am not going to do anything. I do not put the one inside of the parentheses, because if I put the one inside of the parentheses, the compiler, the interpreter, is going to search the one as the name of one instruction. One is not the name of one instruction. One is just the value. What about the return? If the if instruction execute this one, remember, the if return the result of the expression that is going to execute. Just by putting one there, what you are telling is you want to return one. In the previous example, you want to return soon. In the previous one, you want to return hello world. Put the value, put the name of the variable, and that is what you want to return. The return is kind of the instruction implicit if you do not put any other thing. So if the condition is true, one. If the condition is false, okay, here I have a big thing. If the condition is false, let's see, the multiplication of n, and something else. Something else is calling an instruction factorial. Yes, calling an instruction factorial. The parameter for that factorial, remember, the instruction factorial start here and the instruction factorial finish here. This is the name of the function. And this parenthesis here is an instruction. It's not the parenthesis like this. What is the instruction? The instruction is a minus. Yeah, it's an instruction. And n minus 1. Minus n and 1. How many parameters for the factorial? One parameter. The result of n minus 1. Just like this. Whatever is the result of calling the factorial with parameter minus n1 is going to be multiplied times n, and if the condition is false, this is going to be what you are going to return as a result. Now, you are doing a recursive call. What is going to happen? Exactly the same thing that happened in Java when you do a recursive call. You have a stack. Lisp, Java, C, C++, all of them work with a stack and a heap. All of them, when you run a function or a method, you create a copy of that function or that method in the stack. And if you call another function, even if you call the same function recursively, another copy, and this copy have its own variables, local, and it's going to run, and you know. I do not need to explain you how to work with recursion, right? The only thing here is translation from Java to Lisp. Reading the source code in Java, the equivalent with Lisp. When I close this parenthesis, that is the definition of the function, press enter, what you're going to get is the interpreter confirming you that now understand the new function is going to return, remember, the func return the name of the function in uppercase. This is like, I understand. Now I have your function. Now you can use your function because I have your function in my memory. And you can call your function and you can pass parameters, 1. Only one of these two is going to return a result for the 1000. The other is going to have a problem with overflow. The problem, this one work, big numbers, big integers. And you can try two biggest numbers on this one, they are going to work. So functions in Lisp, any questions? I show you easy ones, medium ones, with is, with force, with local variables, and even example with recursion. Hopefully this is clear. Okay. Well, let me be clear regarding the big numbers. The only thing that is happening in Lisp is you have two options when you work with an integer. Option number one is using the primitive data type. The primitive data type is, this variable that is basically 4 or 8 bytes, right? That is the easy option. Primitive data type, integer, you are going to store the number there in a group of bytes. Option number two, and you have this option in Java and in C++, instead of using the primitive data type, what you have is an object. You have a class, big integer in Java. You have a class, therefore you can create an object. This object have inside an array. And when you work with numbers, instead of storing the number in an integer as a primitive element, as a group of bytes in an object, you can store the integer like this in an array in which each of the digits is an integer. So if this one is 4 bytes, here what you have is an array and each digit is using 4 bytes. You are using more memory. You have your number in an array. What you have here is a bunch of methods that are going to do the addition, multiplication, subtraction, division, and so on. Here are the basic operators that the CPU use, plus, minus, division, and so on. Here, there are methods. Instead of working with numbers in bytes, they add, subtract, multiply, and so on, these arrays. You have that in Java. But it's your work as a developer to choose if you are going to use the primitive data type or the classes. For your examples with the factorial, I am sure that in CSI110, you create the factorial solution, the one that I am showing you, using the primitive data. This is an overflow because you are using the primitive data. You can move your implementation in Java from one that use primitive data, integers, float, or whatever, to one that work with objects from the class big integer or big float or whatever. You can move from the primitive data to objects, but it's your choice. It's something that you need to fix. It's something that you need to do. The only advantage with Lisp is you can forget that decision. If you put here a number like 5, the interpreter is the one that is going to take the decision of doing that, the factorial of 5, assuming that this n and whatever is the result here with primitive integer variables. Remember, the data type is something that the interpreter is going to choose to select. But when you put something like this, 1000, the interpreter is the one that is going to take the decision to, you know what, I am going to take this number and I am going to encapsulate that number in an object. And instead of doing the operations with the primitive operators, every single time that you call multiplication or minus or whatever, what is going to happen is I am going to be calling the methods in a particular class or in a particular implementation that I have for big numbers. In the low level, what happened in Java, what happened in Lisp is the same. The only difference is instead of being you, the programmers, the one that should care about, should I use a class? Should I use complex data? Should I use a primitive data? Is going to work with the primitive? Is not? Should I have 2 implementations of the factorial? And you remember which one to call according with the size of the value? The interpreter takes the decision for you in real time. That is the value of this approach, functional programming. You don't care about the data types. You don't care about what is happening below. Remember? A high level of abstraction. High level of abstraction. I want the factorial of 1000. I don't care if that 1000 is stored in bytes directly in the memory, or if that 1000 is encapsulated inside of an object, and that object have methods that are going to work with this number as an array of digits. That is the big difference. Hopefully that clarifies some things. Good. Any other question, guys? So my recommendation, please copy paste all these different examples, all the source code that we review, and please be sure that everything is clear. Moreover, randomly go and open any question, any program that you have, maybe from CSI110, any method that you create with if, else, conditions, maybe conditions inside of for loops, anything that you have. Maybe those methods for searching, printing the numbers, the multiplication table of something, and try to translate them to Lisp. Translate, put your Lisp code in the interpreter, run your code, and check if you were able to create a Lisp version of something that you already understand with Java. Good? So next topic, the last one, I need to talk about data structures in Lisp. And the only data structure that you have in Lisp is lists. That is going to be like what you know as a linked list. But we can talk about this in our next lecture. Good? Any question? Okay, guys, I am going to stop here. See you next lecture. Thank you.